Imagine a world where cars run not on gas, not on electricity, but on something as simple and abundant as air. Sounds impossible, right? But what if I told you that GM's CEO just unveiled a groundbreaking new engine that could make this a reality? An innovation so revolutionary, it could reshape the entire automotive industry? General Motors has made a groundbreaking statement about a cutting-edge zero-emission engine that has the potential to completely change the automobile industry. What is so remarkable about this engine? Its creative reliance on compressed air technology, a long-forgotten idea that GM engineers have since reimagined, is the answer. A lost technology resurrected. The idea of compressed air technology is not new. It was initially investigated in the 1800s and found use in things like mine locomotives and trams in Paris and other places. The development of internal combustion engines, which at the time provided more power and efficiency, eclipsed the technology despite its early promise. The concept reappeared in the early 2010s when Peugeot, a French carmaker, created a hybrid powertrain prototype that combined internal combustion engines and compressed air. This solution maintained an environmentally favorable footprint while doing away with the need for batteries. Peugeot eventually abandoned the project because of worries about economics. It made other automakers, notably GM, interested in compressed air technology. In contrast to Peugeot, GM has fully committed to this technology, spending years on research and development to get over its drawbacks. The operation of compressed air engines, internal combustion engines, and compressed air engines may initially appear to be comparable. Pistons are used in both to create motion, but the propulsion mechanism is where the main distinction is found. Compressed air engines use pressured air to power the pistons rather than burning fuel to produce an explosion. This is an explanation of how it operates. Pressurization. High-pressure tanks, which serve as the engine's energy source, hold compressed air. Piston motion. Air expands quickly when it is discharged into the engine, raising the pressure inside the piston chamber. Mechanical motion is produced when the piston is forced to its full length by this pressure. Spring retraction. The cycle is finished when the piston is pulled back into its starting position by a spring that is linked to it. Exhaust air. The procedure is completely pollution-free because the air leaves the engine unaltered. Why compressed air may be better than ICEs and EVs. Not only is GM's new engine innovative, but it also solves a number of significant issues with existing car technology. Zero emissions. Compressed air engines don't produce any pollution at all. These engines don't produce any negative byproducts, unlike internal combustion engines, ICEs, which emit greenhouse gases. They also sidestep the environmental problems associated with EVs, whose batteries need to be mined for rare earth elements and rely on an electricity supply that still uses fossil fuels. Low costs of production. Compared to constructing ICEs or EV powertrains, compressed air engine manufacturing is far less expensive. Because these engines run at lower pressures, fewer heavy-duty materials are required. Because they use less natural resources, they are not only more economical to create, but also more sustainable. Low operating expenses. The resource of compressed air is cheap and plentiful. Compared to buying gas or charging an EV, refueling a compressed air vehicle is far less expensive. Such vehicles may become more widely available because to their affordability, especially in poorer nations. Infrastructure simplified. Complex fuel supply systems or charging networks are no longer necessary thanks to compressed air technology. Existing air compression systems may be used to swiftly refuel vehicles, which facilitates the technology's global adoption. Compressed air engine difficulties. Compressed air engines have many benefits, but GM needs to overcome a few major obstacles before they can compete. Low density of energy. Compared to gasoline or batteries, compressed air has a far lower energy density, which limits its power output. In comparison to their ICE and EV counterparts, this renders the engines weak, especially for bigger vehicles or high-speed applications. Limited range. The range of the majority of prototype compressed air vehicles is less than 100 miles. For drivers used to the longer ranges of ICEs and EVs, frequent refueling would be inconvenient. Issues with efficiency. A large amount of the stored energy is wasted during operation, making compressed air engines intrinsically inefficient. The financial benefits of using air as a fuel source can be outweighed by this inefficiency. Safety issues. If high-pressure air tanks are damaged in a collision, they could explode. Although some of these worries have been allayed by improvements in design and materials, GM engineers continue to place a high premium on safety. Issues with durability. Compressed air engines' mechanical nature and high running RPMs cause component wear and tear to occur more quickly. Over the course of the vehicle's life, this can lead to increased maintenance expenses. The innovations of GM, overcoming the obstacles. GM has advanced compressed air technology significantly in order to address these issues. Air tanks under high pressure. General Motors has created sophisticated tanks that can hold air at very higher pressures. As a result, the engine performs better and has a higher energy density, placing it on level with conventional gasoline engines. Materials that are lightweight. General Motors has improved safety and decreased car weight by using lightweight, high-strength materials like fiber-reinforced thermoplastics. These materials increase efficiency and range. Reservoirs for integrated air. GM is investigating cutting-edge concepts that transform the car's chassis into a huge compressed air reservoir. This overcomes range constraints by increasing storage capacity without appreciably increasing weight. Enhanced sturdiness. The engines are now more durable due to new engineering methods and materials, which also lessen wear and strain. This improves the lifespan of crucial components and lowers maintenance expenses. A strategic move for GM. GM's choice to focus on compressed air technology is a combination of strategy and innovation. The corporation faces rising pressure to minimize its reliance on ICEs, whose days are numbered due to tougher environmental rules. GM has struggled to establish a firm footing in the competitive EV industry, which is dominated by rivals like Tesla. Historical lessons, perils, and opposition. Despite the enormous potential of GM's compressed air engine, history has some lessons to teach us. Peugeot's hybrid compressed air car, for example, had remarkable results, such as a fuel efficiency of 120 miles per gallon. However, the project was shelved, allegedly because of worries about economics. Since such technology threatens the oil company's business model, there is a lot of speculation that by investing in compressed air technology, GM is putting itself at the forefront of the automotive revolution and showcasing its dedication to sustainability and innovation. The path to this future is expected to be nothing short of revolutionary, so stay tuned. Don't miss out on groundbreaking innovations like this. Subscribe now and stay ahead with the latest in technology and automotive breakthroughs.